So today we're going to be going over the definition of derivative. So you may be wondering, what is a derivative? A derivative is you're trying to find the average rate of change, which is referring back to its slope. So the formula we use to find your derivative will be limit h approaches 0, f of x plus h minus f of x all over h. So remember, this little sign right here, f prime, that equals first derivative. So what we're going to try to do with example 1 is we're going to find our first derivative using the definition of derivatives. So what we first do is we are going to use our formula right above. So what we will do is 2x plus h square minus 16x plus h, don't forget your parentheses, plus 35 parentheses. Also, don't forget your limit h approaches 0. Okay, so we continue. We do negative parentheses 2x squared minus 16x plus 35 all over h. Nice. So now what we're going to do is we're going to distribute and expand the whole equation here where we use x plus h. So what we get at the end from this equation right here is we get 2x squared plus 4xh plus 2h squared minus 16x minus 16h plus 35 minus 2x squared. Remember, we're distributing the negative inside. Plus 16x minus 35 all over h. Also, don't forget your limit. H approaches 0. So now, you may see that there's some variables that we could cancel out easily. An example such as negative 35 and positive 35, that gets canceled out. Positive 16x minus 16x, that gets canceled out. Negative 2x squared, positive 2x squared, that gets canceled out. So what we're left with is 4xh plus 2h squared minus 16h all over h. Don't forget your limit. H approaches 0. So we can see that we could factor out an h from the denominator above. So that's what we're going to do to cancel out the h from the numerator. So limit h approaches 0. H 4x plus 2h minus 16 all over h. And right here we could cancel those h out. So lastly, what we're going to do is we are going to distribute the 0 inside of h. So what we're left with is 4x plus 2h minus 16. So we're going to distribute 0 into h, which this just gets canceled out. So we're left with f prime of x, which you already got your derivative because you performed the whole task of definition of derivatives, and you're left with 4x minus 16. Yay! Example number 2. Okay guys, so now we're going to find the derivative of f of x equals 2x cubed minus 1. So remember, we're going to use the formula right above. So what we do is limit of h approaches 0 to x plus h cubed minus 1 parentheses minus 2x cubed minus 1 all over h. So now what we're going to do is we're going to distribute the cubed into x plus h, which will get x cubed plus x cubed plus 3x squared h plus 3xh squared parentheses. Don't forget your number 2, it's still outside, minus 1. Then we're going to distribute the negative inside these. Negative 2x cubed plus 1. So now what we're going to do is we are going to distribute the 2 inside of all of these. So we'll get 2x cubed plus 2h cubed plus 6x squared h plus 3, danger, remember you multiply. This is 6 x h squared minus 1 minus 2x cubed plus 1 all over h. Don't forget your limit of h approaches 0. So as we see here, we could cancel some of the variables out, such as negative 2x cubed with positive 2x cubed, and then negative 1 with positive 1. So now we're only left with 2h cubed plus 6x squared h plus 6xh squared all over h. Don't forget, limit h approaches 0. So, as we see here, we could factor out an h out of all of these, but we can't factor out h squared or cubed because 6x squared only has one h, so we're only able to factor out one h out of the denominator. So, what we're left with is h squared plus 6x squared plus 6xh parentheses all over h, limit of h approaches 0. So we cancel these out, and now we're only left with limit of h approaches 0, x cubed plus 6x squared plus 6xh. So now what we're going to do is we're going to plug in the 0 inside of h. So 0 squared plus 6x cubed plus 6x0. So these two get canceled out because it just equals 0. And you are left with f prime x equals 6x squared dx. You got your derivative.